Archimedes, born in Syracuse, Sicily around 287 BC, was a beacon of knowledge in the ancient world. His brilliance transcended mathematics, physics, engineering, and astronomy. Archimedes is considered one of the greatest mathematicians of antiquity and of all time. He shaped the course of scientific thought with his groundbreaking discoveries. His inventions, driven by an insatiable curiosity, continue to influence our world today. Archimedes' work was characterized by a rare combination of theoretical depth and practical application. He was not content with merely formulating abstract theorems, he sought to understand their real-world implications. This approach made his work both profound and influential. Archimedes' contributions were not confined to just one area. He excelled in geometry, discovering methods for calculating areas and volumes of complex shapes. He laid the foundation for calculus, a branch of mathematics that revolutionized science and engineering centuries later. His inventions, such as the Archimedes screw and the compound pulley, demonstrated his mastery of mechanics and engineering principles. Archimedes' principle explains why objects float or sink in fluids. It states that an object in a fluid experiences an upward force equal to the weight of the fluid it displaces. Archimedes discovered this while testing if King Hiero's crown was pure gold. The king suspected the goldsmith mixed in silver. By comparing water displacement, Archimedes could detect the fraud. Excited, he ran through the streets shouting, "Eureka! I have found it." Today, this principle is key in shipbuilding, submarines, and hot air balloons. Archimedes was fascinated by geometric shapes, particularly spheres and cylinders. He made a groundbreaking discovery regarding their relationship, proving that the volume of a sphere is 2/3 the volume of a cylinder that can perfectly contain it. He also demonstrated that the surface area of a sphere is 4 times the area of its great circle. To reach this conclusion, Archimedes employed a method known as the method of exhaustion. This technique involves inscribing and circumscribing polygons around a circle or sphere. By increasing the number of sides of these polygons, they gradually approximate the shape of the circle or sphere more closely. This method was a precursor to integral calculus and demonstrated Archimedes' ability to think beyond the limitations of the geometrical tools available at the time. His theorems on spheres and cylinders are not just abstract concepts, they have practical implications in fields ranging from astronomy and geography to engineering and architecture. Section 4, Pi, the enigmatic constant. Archimedes is also credited with making significant strides in understanding pi, the mathematical constant representing the ratio of a circle's circumference to its diameter. He developed a method for approximating pi with remarkable accuracy. Archimedes' approach involved inscribing and circumscribing polygons around a circle, much like his method of exhaustion for spheres. He started with hexagons and progressively doubled the number of sides, calculating the perimeter of each polygon. As the number of sides increased, the polygons began to resemble the circle more closely, and their perimeters provided increasingly accurate approximations of pi. Using this method, Archimedes determined that pi lay between 3/1071 and 3/17, an astonishingly precise range for his time. His work on pi laid the groundwork for centuries of further exploration into this fundamental mathematical constant, which plays a crucial role in various fields, including mathematics, physics, engineering, and computer science. Section 5, Mastering the Art of Leverage. Archimedes' genius extended beyond mathematics into practical mechanics. He famously declared, "Give me a place to stand on and I will move the earth." This reflects his deep understanding of leverage. Archimedes formulated the law of the lever. A moment is calculated by multiplying the force by its distance from the fulcrum. Imagine a seesaw. If 2 people of equal weight sit at equal distances, the seesaw balances. If one moves further, they create a larger moment, tipping the seesaw. Archimedes' understanding led to machines that could amplify force. Section 6, the enduring legacy of a scientific icon. Archimedes' life, though cut short by a Roman soldier during the siege of Syracuse in 212 BC, left an indelible mark on the world. His contributions to mathematics, physics, and engineering were centuries ahead of their time. He explained the principles of buoyancy and leverage, and devised methods for calculating pi with remarkable accuracy. His inventions continue to inspire modern technology. The Archimedes screw is still used today for irrigation and grain transportation. Archimedes' legacy is a testament to the power of human curiosity and groundbreaking scientific thought.